So Andrew writes, can I help him use Global Mapper to download Lidar data? Well, the qualifier from the state GIS website we're going to overlook for a minute. So the first thing that we want to do is get in the area of interest. Here we've got the Bucksport Road in Ellsworth, Maine. I've already brought in this image. You can see the name of it. I've basically exported a section of this GeoTIFF from 2014 and clipped it to this, what we're looking at here. I also have it already with the projection. You can see it down here at the bottom. NAD 83, and this is 2011. And we'll just quickly review that. So I've also set this Maine Central and U.S. Survey feet. So we're working in State Plane Coordinate System, Maine Central, 2000, and we're working in feet. So we're going to say OK, just to show you that. Now, bringing up the online data. So this is from within Global Mapper. We can look at Lidar data from a number of sources. The one that I've got highlighted here is the one we're going to use, the USGS National Lidar Data Set. Okay, and this is going to download via the National Map Download Client. So what Global Mapper is doing is helping us, number one, go to the right site, but also in pre-selecting the area of interest. So we'll say connect, and also to highlight here, select area to download, and the default current screen bounds is what we're going to use. So we're going to say connect, brings up our browser, and here we are looking at an area that fits proportionately into this little box here, but it's pretty much centered on the same area that we have in our GeoTIFF in Global Mapper. So the thing that we're looking for, the data that we're looking for, is over here, and there's a number of things that you can explore, but the one that you're looking for is the one that says Lidar. So we're going to check that. Now, in your email, you just have this qualifier, or that we're looking for Lidar data. So before we actually download anything, we should review what's available. So this is a digital elevation model. So you could, if you wanted to, get a DEM or any one of these other sources. But if we're going to go with just the point cloud, which is already checked, we can leave it go at that. I'd encourage you to explore these other separate downloads. But for now, let's just go after what I think you're asking for. I think what you think you're asking for is Lidar data. So this is the actual Lidar data rather than, for example, a product from the Lidar data. So if we can click on show availability, or we could, which will basically show a bunch of tiles here, or we could just go right to it and say find products. So one of the things that in this screen, on this side of the browser, we see 3 choices, but it's important to note there is actually 4 results. Now in this instance, because of this limited area that we're looking at and the tile sizes, we've got 4 results. So there's a scroll bar here to see all 4. And to see where they are on here, we can say, click on Show Footprints. So we can see we've got a quarter, or maybe whatever, a portion of this one off to the northeast, and maybe almost the full width of a tile over here. But this is the area, these are the tiles, and we're going to just click on Page. So everything on this page, all 4 of these tiles, we're going to say add them. Now we can view the shopping cart, and they use these icons in this lexicon, the terminology, but you don't have to pay for this. This is already paid for. So this brings up those 4 products in your shopping cart. But the first thing you want to take note on here is this is pretty good size. It's 106 megabytes. But if we click on the difference between LAS and LAZ is compression. This is an archived Lidar point cloud, and Global Mapper can digest whatever you throw at it, but the file size for an LAS will be larger than a file size for LAZ. So we're going to click on not removing, but downloading the LAZ. So this will get this one started. Now, note that it's only 9.1 megabytes. So we'll say, okay, save, and then we'll have to navigate eventually to our download directory. I've got my browser configured to save automatically to download a subdirectory. But we'll go on to the next, save, and the next, save, and finally the last one, save. Okay, so let's bring up File Explorer. Let me get this down here so you can see it. I've already set up a folder under Jobs for this tutorial, and it's the first job in 2020, thus 2001, job number 1 in year 20. So here is the Global Mapper workspace, the file that we're looking at here. You'll note up here, 93 Bucksport Road, GMW, that's Global Mapper workspace. So let's go back to see how our download's progressing. So everything's done. And we'll go over to this folder, and we can click on this. We'll just go ahead and just open this folder up. You'll also note that I've recently gotten a daily build. That's this Global Mapper 64 setup file. So we're working with pretty fresh build of Global Mapper. So we've moved those 4 LAZ files into the work directory, and we can go back now to Global Mapper, and you can either add the data with going to File and Open Data. You can go Control O to open data, and because of the directory activity already, Global Mapper knows that we were working in this folder. It automatically opened up, so we can open all 4. Notice that we're not looking at 106 megabytes in total, by the way, or like 38 or something, 38 meg. So we'll say open. Now, at this point, we had got to pause for a second. Since you're on a trial version of Global Mapper version 21.1, and maybe you are, maybe you aren't also test driving the Lidar module, this Lidar options dialog, Lidar load options dialog, may look different. I can't, it's been so long since I've used Global Mapper without the Lidar module, I can't speak to this. So if you see some differences, just try to follow along, while noting it isn't necessary for what you are looking to do, at least what I think you're looking to do at this stage, that you get the Lidar module. Later on, you can evaluate it separately, with Global Mapper later, but at this point, you should be able to do everything that you want to do in being able to read in a point cloud and create some contour lines for a DWG. There's a few steps in between, but you should be able to do all of that with the plain, simple Global Mapper, excluding the Lidar module. Anyway, we're going to create a point cloud. We're going to use these options for all Lidar files in the current group. So we've selected 4. And we would need to go through this dialog each time if this wasn't checked. So all of the Lidar point classifications we're going to import. And that you want to make sure of. We're not going to limit them. We're going to load everything. We could limit them to just what we're looking at, but in order to go over this, we're gonna bring them all in, and we'll just say OK. So we've got 4 tiles, which again, they're going to exceed the area that if we zoom extents, you can do that by just hitting the home key on your keyboard. You can see the full extent. And if we put our photo, we bring our image, we can see the scale of what we're talking about, all 4 tiles. And you can get an idea of the quadrant that we're dealing with. So to go back to our previous view, you can go Control backspace or just hit that arrow pointing to the left. So for right now, I'm just gonna turn off the image for a minute, and you'll notice that these are all looking like the same color, and we can address changing this by how we're coloring. So we could, for example, color the LiDAR by classification. This is maybe default. Because of where I had left it in another job, in another project, it came in the way it did. But I believe that the default, you'll be looking at something color LiDAR by classification. So what we want to do now, the next step after bringing this in, we're looking at, we'll go to our filter, we're looking at everything, all returns, all return types, all classifications. We're looking at everything, but we don't want to create contours with everything. We're going to disable all, and we're only going to choose ground. So this we'll click on apply, say OK. So now, and we can go back and look at the whole neighborhood here. All of these LiDAR points are ground returns only. We're not getting any vegetation or anything else. This is just ground returns. So we are going to next create a surface. And cancel, I should have mentioned, we're going over here to the left and create an elevation grid. I said going over to the left. This is where I've arranged these toolbars. I prefer to have things set up this way. If you're playing around with a trial version, you'll probably see all of these toolbars arranged differently, all scattered along the top, which ends up reducing vertically your real estate that you're looking at. I've tried to minimize that. Also, the control center will be laid out differently. But anyway, you can drag all those around and play around with that later. But the thing that we're going to do is create a surface. And we'll say OK. And we can call it whatever. It's going to create a new layer, and we can call that layer whatever you want. Here I'm leaving the units at feet. And now grid method. Now this binning, I don't believe may be available in the Global Mapper base package. I believe that the only option is triangulation, and this is perfectly fine. There's nothing wrong with this at all. In fact, if we were surveying this, this is exactly the method that we would do between any 3 points, i.e. triangle. We would interpolate the elevations in between each of the lines defined by those 3 points, and thus generate contour lines. So this is a perfectly valid method, and I'm going to choose that because I think that's what you're going to be looking at in your case. Everything I'm just going to leave as is. you should explore and read through this more closely, but I'm just going to click on OK for, oh wait, grid bounds. Why don't we limit to what we have currently displayed? This will speed things up. So we're going to do triangulation of just the points that we're looking at on the screen now. And we'll say OK. So now we have a 3D surface. So at this point, you can immediately begin contouring. Here again, the layer is going to be created called generated contours. Now I already have in mind the interval that we're going to make contours at. So I'm going to call it 2 foot contours. And just to pause on that, because the Lidar point data, I know where it's coming from. This is the Lidar that was created by the main office of GIS, flown in 2010. It has a particular accuracy, and we are not going to be able to, for example, get 1 foot contours out of the data that was collected. It was, it was adequate for many things, but super high detail resolution of the surface, it's not. It's so compelling something at a finer granularity than 2 foot is we're going to be kidding ourselves because of the 15 centimeter criteria when it was flown. The contractor was given a particular accuracy, and that's the product that got delivered. However, all of that said, in areas that are not obscured by trees and nice mown areas, like say the football field over at the high school or someplace like that, where we have unobstructed and reasonably close to ground surface, we actually do have better surface resolution. But generally speaking, 2 foot contours is all we should be looking for. So over here on the contour interval, we'll say 2 feet, not meters, 2 feet. And we're not going to, if you were working around the shore or someplace where you wanted just to see a single contour line of whatever, 0 or whatever you like, then we'd check that. This gives you also down here an idea of the resolution of the this is calculated by Global Mapper, but this will give you an idea of what it's predicting we could get. So what I was just saying about 2 foot and the 15 centimeters and all of that with regard to contours you can feel comfortable with, that are reasonable to use in an engineering application, Global Mapper's analysis of these, what is referring to as fidelity, has it at a little bit better than 2 feet. Here we see something that's a little better than 2 feet. This just helps you evaluate the quality of the contours that you're going to be getting. It doesn't mean that we can go up here and now change that to 1.2 or something. I would not advise doing that. It's a weird interval for starters. But 2 feet will, for generally speaking, be perfectly reasonable for working with the main GIS 2010-2011 data. Other things that we've got down here that you want to take note of. It's not necessary. I may have left this checked one time for something I did last, but appending the units labels, I'm not sure I really care for that. Smoothing the contour, certainly. Now, here again, this is another setting that I may have used, and I'm trying to remember what job it was that I wanted to have feet labeled and the peaks and depressions. But this is good if you're looking for highs and lows and have them mapped. Okay, so I'm going to uncheck that for now. But if you were looking to see where the highest and where the lowest was, the discard closed contour line shorter than, we're going to check that. Okay, this should be checked. And the reason why is because we have all these points, and some of them are going to be creating contour islands. That's what they end up appearing like. And we can limit the number of those little distracting closed contour lines by putting in a reasonable value. If you're on a knoll of a hill, for example, you'd want to see the high points, and so you can imagine what would happen if we put this at 1,000 meters. We would lose maybe 1 or 2 contour lines. But if we say, for starters, we'll see what things look like, but 200 meters. We'll just see with how small these contour lines get, closed contour lines get created here. I've used smaller figures. Let's turn off the point cloud, and here's an example of what I'm talking about. This is an isolated little, it looks like an island, but this little contour line. This one looks certainly quite reasonable. But whether you want these sort of islands showing up in what you're going to produce, it's up to you. But we'll go back to our still getting harassed by mail. Anyway, this 200 meter threshold for contour lines, discarding anything over that length, it seems like it's probably okay for here. Okay, so we've done everything except what you were wanting, a DWG, I think. So let's go back. We'll go zoom our extents. Now, because I've turned off these other things, I hit the home button over here to zoom extents. But because I've turned off everything except the contours, we're zooming extents of visible layers. I don't know if they make that note here. Yes, they do. Zoom so all currently loaded overlays fit in the screen. So this is the only one that we got. This is the only thing that we're interested in. Before we go and create that file, though, that you want to bring into AutoCAD, there's something you may want to do with the data. If we highlight and select, we can select everything on the layer. We have these lines that have a lot of points, and maybe you want to soften this up a little bit or reduce the number of points. This is pretty easy to do, and I think worth mentioning, even though it goes outside of what you were asking for. When we select it all, we automatically invoke the digitizer tool, which we could have also done with the shortcut key Alt-D. But we're going to right-click at this point, and we're going to come down here to reshape. So it was a right-click that brings this menu up. We're going to reshape, that bring up this next menu. Okay, and we're going to simplify. And here we can enter a criteria. For example, we pull this over here. I don't know if can I still zoom in? No. I'm trying to hit the scroll wheel on the mouse to zoom in. But here we see a pretty tight curve. And if we accept that, I want to move that up. Let's just say 10 meters. And we'll say OK and see what happens. So this is exaggerating the effect. Now, I don't believe we can go Control Z. No, we can't. So I'm going to pitch this. I'm going to delete this layer. Yes. Would you like to save your workspace? Yes. Okay. Okay, so we just got rid of that because I can't go Control Z or back out of this or undo it, however you think about this. We can turn this back on. We can hit the home key, zoom extents, and we can do it again. We can create contours. Same thing here, discard. Maybe we move that up a little bit. We'll say 250. Everything else is okay. Oh, but the name. Let's put 2 foot. And of course they're generated. 2 foot contours, a contour interval of 2 feet. Okay, so here we go. And again, this is using the triangulation method. Binning, it goes much faster, and you have a little bit more control over how that binning takes place. But that's in the Lidar module, and again, I don't think that you need to be distracted by that. So just come over here, right-click, and go select all. All right, right-click again, reshape, simplify, and we'll go back to 3 just to see. Oh, and let's go 3 feet also. So that brought the number of vertices down quite a bit. And then if we also look at this, smooth. So this is smoothing it out. Again, I don't know what you're going to be doing, but you ought to be aware that your contours can be beautified. They can be prettied up a little bit by looking at how many points there are and smoothing. Here we have some things that probably shouldn't have been created. We can get rid of. I'm just selecting them. I saw another one up here. So here's a little island. If we Alt-P or click on the information tool, the length of that, I don't think this should have been created. The length of it, it's only 10 feet. So, well, we won't turn this into a troubleshooting beta test or anything. We're just going to get rid of this. So hit Escape, Alt-D, go back to our digitizer tool, and then just hit Delete. So you can clean up stuff like that. You can also move some vertices around, but this is getting out beyond what you wanted. So hitting the home key again, we're going to zoom extents. I see more of these little specks I want to clean up, but I'll let you do that. So now to get it into AutoCAD, we're just going to export it. And so File, we'll start over, File, Export, and we're going to export a vector. And DWG, say OK. Export bounds, we're going to just go with all loaded data, but if we wanted to just focus in on one spot, we can draw a box. And maybe you want to turn on the photo, turn that layer on in order to see it. But I know Route 1/Route 3 is running right through here. You can kind of see it a little bit in the contours. But anyway, we'll say OK, and there's the area. And so export bounds, you want to pay attention to that. Maybe you want the whole thing, whatever. But and then which AutoCAD version you're working with. For me, I would be picking AutoCAD 2004 because that's where my last update was Land Desktop Development, which is got this AutoCAD 2004 engine, but I'm sure you've got something more current. Include display labels. So we're going to get the 170, 172, that sort of thing. If you wanted to, you could have them on a separate layer. Okay. And that's pretty much it, I think. You can go over this further to your satisfaction, but this would get what you're looking for. And we'll just call this 93 Bucksport Road. And of course it'll append it with the DWG. Now before we finish this, notice this little asterisk up here in the name. So this is Global Mapper V21.1, yesterday's build, but also in parentheses is the name of the file that we're working in, the workspace that we're working in. It hasn't been saved. That's what the little asterisk means. So we'll go Control S, and now it's saved. That's pretty much it. Let me know if there's any questions. Talk to you later.